for each of these exam scores. Now, typically what I do is I report my z-scores to 2 decimals, typically the norm. And there we have z-scores generated using the standardized Excel function. Now, if you wanted to, you could even make the z-score formula here even more general. Let's assume that we had not actually computed the mean and standard deviation beforehand. I've created, and so instead I can then use the standardized function, but embed in that the average and so what I'm going to do here now is go up under the equal z-standardized for the very first student and demonstrate how to use the standardized function the same Excel data for computing z-scores. Now let's type in the average function, and the function name is standardized. All of these data points here. Open parenthesis. Now X refers to the exam score, the raw data that and let's now type in the standard deviation, and I'll use the sample formula. And now we're going to enter in again. I will highlight the standard deviations. Let's say that parentheses to close the standard deviation function, the values of 80 close parentheses for the mean, and the value of 7.8 for the standard deviation function. Which this now case I'm going to actually comes from keep constant, and right there we have it a z-score of 0. But that's not a very data point flexible formula or use for finding the mean. And instead, what would be a better use of it is to use the cell references for the mean and for the standard deviation that I've already computed here, and hit return. It doesn't change the value. If I've done this properly and I copy this down, let's go ahead and make these for all the other students. We should see the exact what I'm going to do now is to copy this formula down for the other students. The same z-score values instead of typing it in. Convert those to 2 decimals. Return, and that's how we go ahead copy it down and use the it's going to keep standardized function, the location of the mean for standard deviation. But it will adjust then the X value demonstrated how to do it a couple value down for each individual. Now I'm sure that you can see that I don't even need to use the standardized function in Excel to compute z-scores. Let me go ahead and just demonstrate how I would compute it using the formula the norm x sub I minus x bar, and there we have whole quantity divided by generated deviation standardized so equal Excel function x. Now if you wanted to, you could even make x bar the z-score and I'll put formula here even more general. Let's assume that we had not actually computed the mean and standard deviation beforehand, and so instead I can then use the standardized function, but embed in reference the average and standard deviation functions and standard deviations fixed standardized. Open parenthesis, and as again the same raw data, notice it's identical to what. Now let's type in the average function, or I can make this even more of all of these sophisticated formula, if you will, more complex. There we go. By equal, again, take the raw and let's score now type minus, and let's say I use instead the average function, that function name, and again I will already compute the cases, mean, close parentheses to close the standard deviation function, divided by, and then close parentheses to complete the standardized function. Now I'm going to keep constant. Make sure I get the parentheses correct. I want to have a parentheses of data around the x sub I for finding the mean and for finding the standard deviation. And now I also want to make sure that the reference to the range that contains the data for finding the average is fixed. There we go. And I will do the same thing. And if I've done this properly and I copy this down the cell for all the other students, we should see the exact same z-score values. Deviation, and to make it clear that the same z-score values, I'll convert those to 2 decimals. Look at it, make sure. And that's how we go ahead and I think we've use the standardized function in Excel. Now as I copy this down, computing z-scores. Again, it generates the exact same. And I've demonstrated how to do it a couple of different ways. So whether we use the standardized function, that I don't even need to use the standardized function in Excel, type in ourselves the complete formula. Let me go ahead and just demonstrate how I would compute it using the in Excel formula to convert exam scores x bar raw scores that whole quantity divided by the standard deviation. So equal x minus x bar, which is the mean, and I'll put that in parentheses. divided by the standard deviation for that variable. And what I want to do now is to make the reference to the cell that contains the mean and standard deviations fixed. Now that we've computed z-scores for our original exam scores, we can go ahead and use another Excel
standardized function
to find the percentile,
or I can make this even more z-score value.
Sophisticated.
What I'm going to use here is going to be the norm.s
by
function.
Again, take the raw score minus, and let's say I use instead
the norm refers
the
to the
average
normal
distribution,
as
I
does
had
the
that
already
distribution,
computed
obviously.
mean,
And the S refers to
parentheses,
standard normal distribution
divided
now
by
the standard normal distribution is the version
standard
of
deviation,
the normal
the sample.
distribution that has a mean of 0 and a standard deviation,
for the standard
of 1.
deviation.
Now let's make
Open
sure I get
parentheses.
the
Now
parentheses
we then
correct.
highlight
have a parentheses the z-score
around
value.
the
We want to
x of
find
I
minus
the
the
percentile
percentile for. That looks correct.
comma,
And now I also
and now
want
we
to
type in a
make
value
sure
of
that the
1.
reference to
The
the
one
range
refers
that
to
contains
a cumulative
the data for finding the
distribution.
average.
The cumulative
is fixed.
distribution refers to the idea of
And I will do
the
the same thing
percent
then
of the
for
area under the curve, or the
cell
entire area
references
under the
for the
curve that
range
falls at
that
or
we
below
use
a given
for
z-score
finding
value.
the standard
And that's what we
deviation
want for a
the data.
percentile. And hit return, and we see it has a value
Take
of
a quick look at it, make sure
0.50.
that looks okay.
Now
I
this
think we've got it.
0.50 here is
Go ahead and
proportion
hit
of the area
return.
under the curve.
And now
Typically
as I
what
copy
we'll
this
do is
down,
we'll report percentiles
again it generates the exact
as
same
though they are percents. So we'll
values.
multiply this
So
by
whether we use the
100,
standardized
not as
function,
portion,
but
or
as a percent,
we just
and there
type
we
in
see
ourselves the
50,
complete formula for a
50th
z-score.
percentile.
It's pretty easy.
So
An
you can
exam
see
score of 80
in Excel
when
to
the mean
convert
for a group
exam
is 80
scores
has a
or raw
percentile
scores
value
into
of the 50th
z-score format.
percentile.
And I'll go ahead and I'll drag that all the way down. And what you'll notice here now we have percentile values for each one of our exam scores. Now typically percentile values are rounded off to the largest whole number, and so let me go ahead and do that. And right there we have it. Percentile values that were identified once we have z-scores using the norm.s.dist function. Now that we've computed
But we can
z-scores
actually
for
find
our original
percentile
exam
values
scores, you can go ahead and use
straight from the
another
raw exam
Excel
scores
function
themselves,
without
to
even
find
having to
the
compute
percentile
z-scores. Let me show you how to do
each
that.
z-score value.
So I have here a
I'm going to
second
use here
sheet
is
here
going to
for
be the
percentiles, and you notice I do not
norm.s.dist
have
function.
a z-score computed for each exam score.
Norm.s.dist.
What
Now,
we're going
the
to
norm
use here is
refers
going to
to
be
the
the
normal
norm
distribution
dot
as
dist
does the
function, distribution obviously, and
the
again
S
refers to
the
standard
value
normal distribution.
Now the standard normal distribution is the version of the normal distribution.
And now we have to tell
that
it
has a
exactly
mean of
which
0
normal distribution
and a standard
and that requires us
deviation
identifying
of
the
1.
mean and the standard
Open
deviation.
parenthesis.
So
now
we'll come
we
down here and
then
identify
highlight
the mean for our
the
exam
z-score value.
scores. We want to find
comma,
the
and also
percentile
the
for
standard
deviation for our
comma,
exam scores.
and now we type in a
Comma,
value of 1.
and one last
The
parameter
1
we have
refers
to
to
specify,
a
and
cumulative
that being a value
distribution.
of 1.
The cumulative
The 1
distribution refers
cumulative.
to the idea
All
of
the area
the
under the curve
percent
up to
of the
and
area
including
under
a
the
given
curve, or
exam
the
score.
entire area under
Now
the
I'll
curve
hit
that
return,
falls at or below a given z-score value.
and let me
And
go
that's
ahead
what we
since I'll
want
copy
for
down
a percentile.
this formula and
Just
hit
return,
return.
and we see it has a
Let me go
value of
ahead and make
0.50.
sure then that I have
Now this
a
0.50
fixed
here is
reference for where
proportion of
the
the area under the curve.
Typically what we'll do is we'll report percentiles, standard deviation,
as though
and
they are
mean
percent
values
so we'll
are.
multiply this
But in
by
addition to
100.
that, not as
The
proportion,
0.5 refers
but
to
as a
proportion
percent.
of the area
And
under
there
the
we
curve
see
at or below
50
an exam score of 80.
50th percentile.
When the mean of the
so
whole
an
group
exam
is 80.
score of 80.
What we
want to
when
do
the
is
mean
now
for a group
multiply
is
that
80,
by
100,
100 percentile
so it's
value
percent
of the area under the curve. And I'll go
Let's put
ahead
that
and
at
I'll
the end
drag
here of our formula.
that all the way down. And what you'll notice
Hit
here now we
return,
have percentile
and now it's
values for
percent
each
of
one
the
of our
area under the curve
exam
at or
scores.
below that
Now
exam
typically
score,
percentile
which is
values are
50%,
rounded off to the
50th
largest
percentile.
whole number.
Click and
So
drag
let me go
down.
ahead and do that. And again, I'll just go ahead and reduce that. And right there we have it. Percentile values
No
that
decimal
were
points.
identified
places, rather, I should say.
once we have
So what we
z-scores
have here now
using the norm
is
dot
the
s
percentile
dist
values
function.
in
But we can actually find
whole digits.
percentile values
straight from the raw exam
now
scores
that we work
themselves,
from raw score
without
to
even having
z-score to
percentiles.
let me show you how to
what
do
I want
that.
to do is demonstrate how we
So
can
I have
work
here
from
a
percentile and go
second
backward
sheet here
to
for percentiles,
z-score,
and you notice I do not have
raw
score. A z-score computed for each exam
The first
score.
illustration of
what
this,
we're going to use here
let's
is going to be
assume
the
that
norm
once we've computed our
dist
z-score values
function,
for each student in this class,
and again identify
I then decide
the
as the
value
instructor to curve the grades
of the
and
exam
looking
score
at
we
my
want to find a
percentage distribution
percentile
over
for,
here,
comma,
let's say
and
I
now we have to tell it
decide
exactly
then that
which
the
normal distribution,
highest
and that requires
7%
us
of the
identifying
exam
the mean
scores will be
and the
awarded
standard
an A.
deviation.
The
So we'll
next
come down here and identify
24%
the mean for
in
our
rank order would
exam
be awarded
scores,
a B. The
comma,
middle
and
38%
also the
would be
standard
awarded a C.
deviation for our
The
exam
next
scores.
24% in rank order would be awarded
comma,
a D.
and one
and
last
the lowest
parameter we have to
7%
specify,
would be
and that
awarded
being
a
value
and
of
F.
1. The one
Well,
refers to
when we
cumulative.
think about that, then,
all the area
what
under
that
the
would
curve
translate
up
to
and
is, first of
including
all,
a given
the
exam
7th
score.
percentile and below
Now I'll hit
represents the
F range.
and let me go ahead.
The
Since I'll copy
31st
down
percentile indicates
this
then the
formula in
highest
just a moment.
value for
falling
go
into the
ahead
D
and
range.
Make sure
The
then that I have
69th percentile,
a fixed
what I'm doing
reference
is
for
adding
where
these
the
percentages
as we go up.
represents then the highest
Standard
value, but
deviation
still falling in the
and
C category.
mean
The
values are.
93rd percentile,
But in addition to that,
then would be the highest
0.5
value,
refers to
but still falling
proportion
into
of
the B
area under the
category,
curve
and
at
all
or
those
below an
above it
exam score
would be
of 80,
awarded
when
an
the
A.
mean of the whole group
Now
is 80.
you'll notice here
What
that
we want to
under
do
this
is
column
now
I have
multiply
a
that
value
by
of
100, which is
100,
nothing more than a
so it's
percentile
percent
of the area
in
under the
proportion
curve.
form.
Let's
And
put
that's
at
what
the
we
end here of
need
our
to
formula.
enter when we actually then
Hit return,
compute
and now it's
the
percent
Z
of the area
scores
under the
based
curve
on a
at or below
percentile.
the exam score.
What I'm going
which
to
is
use here
50%,
is going to be then,
percentile.
and I'll start right up
Click
here
and drag
with
down.
the B
And again, I'll
category
just go
here,
ahead
is going to be the norm
and reduce that
S
to
inverse function
equal
no
norm
decimal points dot S, and
No
again
decimal
the S
places,
refers
rather,
to
should
the
say.
standard
So
normal
what we have
distribution
here now
is the
inverse, so
percentile
working
values
backwards
in open
whole
parentheses.
digits.
Now all I do is identify then what is the probability.
Now that we work from
this
raw
probability
score to
value must
z-score
be
to
between
percentile.
0 and 1.
So
What I
it
want to do
cannot
is
be
demonstrate
0,
how
it
we can
cannot
work
be
from
1.
percentile and go backward to
Close
z-score
parentheses
or to
and hit
raw
return.
score.
And I'll
The first illustration of
drag
this,
that down for each
let's
one of
assume
these.
that once
So
we've
you notice
computed
just
our z-score
highlighting this
values
here,
for each
this goes and
student
finds
in
then
this class, I
the
then
z-score
decide as the
associated
instructor
with
to curve the grades.
a
And looking at
probability
my
of
percentage
0.69.
distribution over here,
This
let's
next,
say I
a
decide
probability
then that the
associated with
highest
0.31,
7% of the
and
exam
next,
scores
the
will be
probability
awarded an
associated
A.
with 0.07.
The next
And let me go ahead
24% in rank order would be awarded a B.
and
The middle 38%
reduce
would be
this
awarded
to
a C.
two
The next
decimals. Now, I
24%
do not have a
rank
value
order would be
that's
awarded a
reported
D,
up here,
and the lowest 7%
and let me show you what
would
happens
be
when I actually
awarded
do
A and
then.
F.
I'll put here
Well,
a
when we think about that,
probability
then,
of
what that would
1,
translate
which would be the
to is,
highest.
first of
100
all,
would be
the
the
7th
highest
percentile
value
and
here,
below
the 100th
represents the
percentile,
which you never
the
really hear
F range
anyone
referring to
the
100th
31st
doesn't make
percentile
sense
indicates
statistically.
then the highest
And we'll
value
show you
for
why.
falling into the D
norm
range.
dot
The
S
69th
dot inverse.
percentile,
What I'm doing is
open
adding these
parenthesis,
percentages
click on the
as we go
probability
up,
of 1 represents
return,
then the
and it
highest
returns an
value
error
but still
message.
falling in the C category. The
Statistically, it
93rd
doesn't make sense to
percentile
refer
then
to
would be the highest
the
value
100th percentile,
but still falling
and
into
that's
the B
why it returns an
category,
error
and all
message.
those above
So
it
the
would be
probability
awarded
values here
an A.
must
Now,
be between
you'll notice here
0
that
and 1.
under this column I have a
And that's
value
what
of
we're
K,
left
which
with
is
right
nothing
here.
more than a percentile.
Now we can do the exact same
in
thing
proportion form.
if we look
and that's
just
what we
at the
need
exam
to enter
scores.
when we actually
what
then
is the percent
what is the
compute,
exam score
the
value
z-scores
that
based
is
on
at
a
the
percentile.
93rd percentile.
What I'm
and
going
so
to
on.
use here
and what
is
we'll
going
do
to be
here
then, and I'll
is now
start right
use
up
the
here
norm dot
with the
INV,
the
B
inverse
category here
norm function
is going to be the
So
norm
equal
S
norm
inverse
dot
function
INV
equal norm.
and you notice we have
dot
more
S, and
information
again, the S
we have
refers
to
to the
identify
standard
here.
normal
To
distribution.
first of all specify the
Dot inverse,
so working back
the,
the probability value in a proportion.
open parentheses.
So
Now all I do is
0.93 refers to
identify
the
then what is the
93rd
probability.
percentile, or 93%
This
of the
probability
area under the
value
curve.
must be between 0 and
comma.
1. So
Now
it
we
cannot
identify
be
what the
0, and it
mean
cannot
value
be
is
1.
for this distribution,
Close
comma,
parentheses.
and identify what the standard
And hit
deviation
return.
value is for this distribution.
And I can drag that down
and now
for
we
each
hit
one
return.
of these.
So you notice just
and let's
highlighting this here. This goes and finds then
now
we want to copy
z-score
this formula
associated
into the
with
cells below a probability of 0.69. This
so
next
let's go ahead and make
probability
the
associated with
the cell that contains the mean and standard deviation
values.
The probability
as
associated
fixed
with
references.
0.07.
And now let me go ahead, drag this down, and let me go ahead and reduce this to whole numbers, which is what the. Now I do not have a value that's reported up here.
The exam is graded.
And let me show you what happens.
So
when
in
I
this case, it indicates that
anyone who scores at 68 or below
probability of
will
one,
be awarded an
be the
F.
highest.
That's the
100
7th
be the highest
percentile
below
value here.
Anyone who scores now
between the 7th percentile,
which you never really hear
and the
anyone
31st percentile will receive a D,
statistically,
and that's a value
and we'll show
of
you
76.
Equal
anyone who
norm
receives an 84
S
down to
inverse
just above the 76
click
will
on the
be
probability of
awarded a
1
value
and hit return.
C, and anyone who scores from 92 down to just above 84
statistically it doesn't make
will be
sense
awarded
to
a
refer
B,
to
and then anyone who
the
scores
100th
above
percentile.
a value
And that's what
of
returns an
92
error
will be awarded.
So the probability
then an
values
A.
here
And this is how we
must
can
be
go
between
from
0
the
and
percentile
1.
value and now go right
And
back
that's what
to
we're left
find
with
what
right
the
here.
raw exam
Now
score
we can do the
is by
exact
using the
same
norm
thing
dot
if we
inverse
look just
function.
at the exam
Another
scores.
example where we
Ask
might
what
see
is the
that this may be
percentile-
useful of
what-
going from
what is
the
the exam
percentile
score
back to
value
a
that
score
is at the 93rd percentile.
relates to
And so
membership
and what
in
we'll do
the
here is now
International
use the
Mensa
norm
Organization.
.inv.
The Mensa
the
Organization
inverse
is the
norm
largest
function.
and oldest high
So
IQ society in the world.
norm
In order to
dot
qualify
INV,
for membership in
you
Mensa,
notice we have
people
more
must
information
score
we
at
have
or
to identify
higher
here.
than the 98th
First of
percentile
all, specify
on an
the
approved IQ test
the
or other
probability
intelligence
value
test.
in a proportion.
And perhaps
So
the most common
0.93 refers to
IQ
the
test is the
93rd
Wechsler
percentile,
Adult
or
Intelligence
93% of the
Scale,
area
or
under the curve.
WAIS, and its
Fourth
fourth
edition
Now we identify what the mean
was,
value is for this distribution,
provided in the year 2008.
Now
identify what the standard
this
deviation
particular
value
IQ
is
score,
for this
IQ
distribution.
test rather, has an average for the population
hit
of
return.
100 and a standard
let's do-
deviation of 15.
Let's go ahead and
With
now
that being the case,
we
and
want to
if we
copy
have
this
to
formula into the
meet,
cells below.
be at least at the 98th percentile, what is the minimum IQ
so let's
score
go
in this
ahead and
particular
make
test
the
that we need to
reference the
attain
cell
in
that
order
contains
to
the mean and standard
qualify for
deviation
membership in
values
Mensa?
as
So in this
fixed
case, what I've done
references.
here is I've identified
Now
98
I can
percentile.
drag this down.
Now I'm going to
And let me
equal
go ahead
and
norm
reduce this
inverse,
to whole numbers,
and now
which
the
is what
probability
the
is 0.98.
that
There,
K
which is what the
column
exam is graded
is representing the percentile.
So in this case,
in
it indicates
proportion,
that
which is what we need
anyone
for
who scores at 68 or below
its use
in
will be awarded
Excel,
an F. That's
here in
the
this
7th
norm
percentile
inverse
below.
function.
Anyone
comma,
who scores now
the
between
assumed
the 7th
population
percentile
average,
and the
comma,
31st percentile
the
will
assumed
receive
population
a
standard
D,
deviation,
and that's a
close
value of
parentheses,
76.
and hit return.
Anyone who
and now it
receives an
indicates
84 that
down
you need,
to
and let's go ahead
just
and
above
I
the
think
76
the IQ test
will
is
be
scored
awarded
in
a
terms of whole
value
numbers
of
C.
Let's go ahead and
anyone who
reduce that
scores from 92 down to just above
to
84
whole numbers
will be awarded
and in
a
that
B,
case,
and then anyone who
needs to
scores
score
above
a 131
value
or
of
higher
92
will
on
be
the Wechsler
awarded
Adult
then
Intelligence
an A.
Scale. And this is how we can go from
in order to qualify
the
for
percentile
membership
value and
into
now go
Mensa.
right back to
So
find
hopefully
what
now
the
you've got
raw
a good
exam
sense as
score
to
is
how
by
we
using
can
the
go from
norm
raw data to
inverse
z-scores to
function.
percentiles.
Another
and
example
from
where we might see that this may be
percentiles
useful of
back to
going from the
z-scores and also
percentile
to
back
raw
to
scores.
a score relates to membership in the International Mensa Organization. The Mensa Organization is the largest and oldest high IQ society in the world. In order to qualify for membership in Mensa, people must score at or higher than the 98th percentile on an approved IQ test or other intelligence test. And perhaps the most common IQ test is the Wechsler Adult Intelligence Scale, or WAIS, and its fourth edition was provided in the year 2008. Now, this particular IQ test has an average for the population of 100 and a standard deviation of 15. With that being the case, and if we have to be at least at the 98th percentile, what is the minimum IQ score in this particular test that we need to attain in order to qualify for membership in Mensa? So in this case, what I've done here is identified 98 percentile. Now I'm going to equal norm inverse, and now the probability is 0.98. That K column is representing the percentile in proportion, which is what we need for its use in Excel here in this norm.inverse function, comma, the assumed population average, comma, the assumed population standard deviation in close parentheses, and hit return. And now it indicates that you need, and let's go ahead, and I think the IQ test is scored in terms of whole numbers. Let's go ahead and reduce that to whole numbers. And in that case, one needs to score a 131 or higher on the Wechsler Adult Intelligence Scale in order to qualify for membership into Mensa. So hopefully now you've got a good sense as to how we can go from raw data to z-scores to percentiles, and from percentiles back to z-scores and also to raw scores.